Hello and welcome to my terrains project. This project was done as part of some research through the Ohio Space Grant Consortium, so I'm going to dive a little bit into what the research looked like and what we did to create these Mars terrain visualizations. So first, downloaded terrain digital elevation models from the USGS. These are for the entirety of Mars. These were taken on the Mars Orbiter laser altimeter through a number of years on a number of varying missions, from the Viking missions to more recent ones in the early 2000s. Basically what we did with this was we converted it to a triangulated mesh, which you can see here. This is just a very, very, very small portion of that entire mesh, but as you can see, this is what it roughly looks like. Once we got this mesh, we had to do some post-processing in Blender, because as you can imagine, the vertices were all relative to the Mars localized values. So even when we were taking very small sections of this, they'd be like way, 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 way off in the distance. You wouldn't be able to see them because like the height would be relative to Mars and not to our viewer or engine or whatever we have. So some post-processing was then done in Blender. After that, we took that OBJ file and got it loaded into here. Let me expand this a bit. So we put this into OUNPPM because we were trying to explore how ground navigational aids can be used on Mars and in Mars terrain. As you can see here, this is just like little default terrain. It's not texturized and colorized as well as I would like it to right now, but it works for the time being. I also got some transitions and translations coded in here for the model so that I could take some better pictures with it. This program works for any, or should work for any geotip that has DEM data, and allows us to view pretty much all of Mars. And in a second here, I will load in a larger model. However, that model will take a long time to load, so give me 1 second. So here I have pulled up a much larger terrain, and I'm very high up right now. As you can see, it's struggling a little bit, but it is capable of loading much larger ranges of data too. So you can just see some pretty cool features such as those larger craters over there, or this one right here, and the ability to load large sections of terrain. This complete model can also be viewed here as well, although it does certainly lag the system a little bit. And the reasoning for this is because when mesh generation was done, this is a very large amount of data, and along with that, it has, you can't see it, it's off the side here, but roughly 12.5 million triangles. So you can see very quickly how dense this whole mesh is. And this is really challenging the computer, but as you can see here, I managed to zoom in on a crater here, and you can kind of see some of the triangles in there and the cool mesh triangulated out. But yeah, that is my Mars terrain data. Thank you for watching.